All right, so we've got two more examples here. And in both of these examples, we want to find the extrema of this function on the interval. So we want to find the absolute maximum and absolute minimum values of both of these functions. Okay, now the first thing we're going to start with is we want to start by finding the critical numbers in this function over our interval. Our critical numbers occur when the derivative of f of x is either undefined or if it's equal to 0. And so let's start by finding this derivative. So f prime of x. Now, to find the derivative of x e to the power of x, I see that I have x that is being multiplied by e to the power of x. And so for that, I'm going to need to use the product rule. So taking that first function x, multiplying it by the derivative of the second function, I know the derivative of e to the x is just e to the x, plus that second function of e to the x, times the derivative of the first. The derivative of x is just 1. Okay, and this is going to give me a derivative of x e to the x plus e to the x. Now I'm thinking, is there anywhere where this is going to be undefined? No, because I know that I can plug any value into the e function, any value into x, and it's going to be defined. I don't have any kind of square roots, I don't have any logarithms, I don't have any denominators here that can be zeros. And so I'm just looking for the values where the derivative is equal to 0. And so I want to solve this equation. Now this is extremely difficult to solve as is, however, I see an e to the power of x in both terms on the right-hand side. And so I'm going to factor out that e to the x. When I do that, this leaves me with an x plus 1. Now because this is set equal to 0, I can use that zero product property and say that this equation is going to be true if either of these factors is equal to 0. And so I've got two equations now, that e to the x can be 0 or x plus 1 can be equal to 0. Let's start on the right. Okay, I can bring that 1 to the other side. I get x equals negative 1. All right, so this is one of my critical numbers. Now for this equation. So here's what I'm going to do. I'm going to try to isolate that x. This is my goal. I want to try to isolate that x. And I'm thinking, what's the opposite operation of e? So how can I undo that base of e? How can I get this x out of the exponent? And I can do that by taking the natural log of both sides of this equation. Okay, so I'm going to take the natural log of both sides of this equation. Scooch this over a little bit. Okay. And so now, on the left, because the natural log and e canceled each other out, I am just left with x. So that's nice. So I've just got an x on the left-hand side, and now the natural log of 0. All right, so I'm thinking the natural log of 0 might be one of my solutions, but let's go to our calculator. If I type in the natural log of 0, look what I get. I get this error domain. And so what this tells me is that the natural log of 0 is undefined. If I go to graph the natural log of 0, so I can do this, I can graph the natural log of x, and let's go to a standard window, and look what I really see here. I really see a vertical asymptote right down here. So this curve really gets closer and closer to x equals 0, but x cannot be equal to 0. And so this leads me to a dead end. Since x equals the natural log of 0 is not a real number, my only critical number is x equals negative 1. So this is my critical number. All right. Now that I have that critical number, I'm going to test the critical number along with the endpoints. So I am going to test x equals both of my endpoints, -2, my critical number of -1 and 1. All right, just testing all of these. Now I want to plug these into my original function. I could do this in the calculator, but look, I've got an e, and I don't want a decimal approximation of my final answer, so I'm guessing I'm going to have to do this by hand. And so I can find f of, if x is -2, I'm going to get, just plugging -2 in for x, I get -2 e to the power of -2, which is, and I can write this -2 over e to the power of +2. All right, this is kind of as simple as I can get. So let's find those other two values, f of -1. All right, this is going to give me -1 e to the power of -1. And I can write this as -1 over just an e to the power of 1 in the denominator. Okay, one more. I've got f of 1. This is going to give me 1 times e to the power of 1, which is just e. So now I'm looking for the largest and the smallest value on this interval. Now I've actually only got one positive value, and so e is definitely going to be my max. So my max is definitely going to be e. It's the only positive value. And then I just have to see which is smaller between these two, and I can estimate that in my calculator. So let's see. -2 divided by e squared. Okay, this is my decimal approximation, about -0.27. And then -1 over e. -1 over e, -0.36. All right, this one is definitely smaller because it's negative. And so this will be my min, -1 over e. All right, so that is my max and my min. And we could check these in the table and graph of our calculator, but we showed that in the last video. So go ahead and look at that last video to see how you can check these answers in your calculator. Okay, I just wanted to focus on some of the algebra with these two problems. We've got one more. F of x equals x to the power of -2 times the natural log of x. As we go from 1/2 to 4. I want to start by finding those critical numbers, which is where the derivative is equal to 0. So let's start by finding the derivative, or where the derivative is undefined. So finding this derivative, I see, now there are two different ways I could go about this. X to the power of -2 times the natural log of x. Here, I've got a product of two different functions. The other way I can look at this is the same as f of x is equal to the natural log of x divided by x squared. So you could also use the quotient rule. So I could look at this as a product or as a quotient. Whatever you prefer. If you would rather work with a product and you're okay with that negative exponent, then use the product rule. If you would rather avoid a negative exponent, but you're okay with a fraction, use the quotient rule. It is up to you. So I'm just going to use the product rule here. This is going to give me first x to the -2, d second, so the derivative of the second function, derivative of natural log of x is 1 over x, plus second, so natural log of x as is, d first, so the derivative of x to the -2, so now I'm using the power rule. So this is going to be -2 x, and then subtracting 1 from that power gives me a power of -3. All right, let's simplify this as much as possible. This is going to give me x to the negative 2 times 1 over x. All right, well this is really, so when I simplify this, I'm actually just going to make all of my x exponents positive, just for ease. A power of negative 2 in the numerator. This is the same as x to the negative 2 in the denominator. And so I can say that this is 1 over, my denominator is going to be x squared times x. So I can move this term to the denominator and make that exponent positive. And let's simplify this over here to the right. So to the right, I have a negative. Let's see, I've got a 2 and the natural log of x that can stay in the numerator, and then my denominator. I can move this x to the power of negative 3 down, and I've just got x cubed. Now look at what I have. X squared times x, well that's x cubed. And so now I can combine these fractions, and I can write this as a 1 minus 2 times the natural log of x over x cubed. So this is my derivative. Okay, now we said that we would have a critical number where the derivative is either equal to 0 or undefined. So if the denominator is 0, a number is undefined. So I can set the denominator equal to 0. And so I'll say 0 is equal to x cubed. This would give me one critical point, or multiple critical points. And then when the derivative is equal to 0, I've also got a potential critical number. So now let me set the numerator equal to 0. So I've got 1 minus 2 times the natural log of x is equal to 0. This will give me another critical number. So let's solve both of these equations, starting on the left. To undo that cube, I can take the cube root of both sides of the equation. So I'm going to take the cube root of 0 and the cube root of x cubed. So the cube root of x cubed on the right, well, that undoes that cube, so that leaves me with an x. So the cube root of 0 is still 0. And so my first critical number is x equals 0. So now let's look at the second equation. So to keep everything positive, I'm going to move the 2 times the natural log of x over to the right-hand side of this by adding. So I'm going to get 1 is equal to 2 times the natural log of x. All right. I want to isolate this x as much as possible. So now I'm going to just divide both sides of this equation by 2. And are we okay if I just switch the order, just to keep my x's on the left? So I'm going to say that 1/2 is equal to the natural log of x is the same as the natural log of x equals 1/2. I just moved this term to the other side. Okay? Now, I remember that when I had an e to some power, I undid that e by taking the natural log of both sides. Well, I'm going to do the opposite here. If I want to isolate that x, I'm going to raise both sides to the power with a base of e. So I'm going to kind of base e both sides, if you want to call it that. So e is going to be my base, and these are going to be my powers on both sides of that equation. So I'm going to have e to the natural log of x on the left, and this is equal to e to the power of 1/2. So I just made both of these my power. Now this is okay because I did the same thing to both sides of the equation. And now on the left, this e and natural log canceled each other out. So I am just left with x equals e to the power of 1/2. Or there's another way I can write this. I can also write this as x equals, well, a power of 1/2 is the same as a square root. So I can write this as x equals the square root of e as well. Now I've got my two critical numbers. Of 0 and the square root of e. And so now this is what I'm going to test. I remember that I have to test both of my endpoints and my critical numbers. And I just want to ensure that both of these critical numbers are on the interval, because I don't want to test any critical numbers on the interval. Well, is 0 on this interval from 1/2 to 4? No, it is not. So this is not a critical number because 0 is not in the interval from 1/2 to 4. And so now the square root of e, well, I know e is about 2.71, and that square root is in fact greater than 1/2 and less than 4. I could check that in my calculator too. And so these are the points I'm going to test. Now I'm just going to test x equals 1/2 the square root of e and 4. These are my three numbers. These are my three potential maxima or minima. And I'm thinking I might try using a calculator to plug these numbers in, but I've got some natural logs, I've got an e, so it's likely it'll get pretty messy and it won't be just a constant. And I need the exact answer, so my calculator is only going to give me the decimal approximation, which I don't exactly want. And so let's plug these in by hand. Now you can use whatever version of this function you want. I might actually use this one on the right. I think it's going to be a little bit easier. I'm going to use f of x is equal to the natural log of x divided by x squared. So I'm just going to plug all of these x values into this function, and I get that f of 1/2 is equal to the natural log of 1/2 divided by 1/2 squared. All right, simplifying this. So the natural log of 1/2, let's remember those rules of logarithms. When I have the natural log of a quotient, I can actually separate this by subtraction. So this is the same as the natural log of 1 minus the natural log of 2. This is all being divided by 1/2 squared. Well, that's just 1/4. Now the natural log of 1, remember, the natural log of 1 is just 0. So I'm just left with a negative natural log of 2 in my numerator. When I divide by 1/4, it's the same as multiplying by 4. So f of 1/2 is equal to negative 4 times the natural log of 2. So this is my simplified version of f of 1/2. Now also calling this positive 4 times the natural log of 1/2 would be fine as well. Now what about e? So now I want to find f of the square root of e. This is going to be the natural log of the square root of e divided by the square root of e squared. Okay, now I'm guessing that the natural log and e are going to cancel out somehow, but I want to know what I need to do about this square root. And to more easily see that, I'm going to write this a little bit differently. Now the square root of e I know is e to the 1/2, so I'm going to write this as the natural log of e to the 1/2 power. My denominator, well, the square root of e squared is just e, which is nice. Okay, now remember that power rule of logarithms? That tells me that, and this is not the same as the power rule for derivatives, just for logarithms in general, that this 1/2 has the same value in the exponent as it does in the place of the coefficient. So this is the same as 1/2 times the natural log of just e. These are the same exact thing, not taking that derivative, just using the rules of natural logarithms. And I remember that the natural log of e, because these guys undo each other, the natural log of e is just 1. And now I have 1/2 times 1 divided by e. So 1/2 divided by e is the same as 1/2e. So this is f of the square root of e. Okay, and one more, I now need to find f of 4. This is going to be the natural log of 4 divided by 4 squared. Natural log of 4 is just the natural log of 4. There's really nothing else I can do to that. And I'm dividing that by what 4 squared is 16. And so the only other way I'm really going to need to write this, and I can just write this as 1/16 times the natural log of 4. It doesn't really matter. Both of these are perfectly acceptable. Okay, so I've got my candidates for the maxima and minima. Now I think I'm going to need my calculator for this. One thing I don't think I'll need is that this -4 natural log of 2, this is the only value that's negative. Because of that, I can pretty safely assume that this is my min. This is my min. You can note that that's a negative. All right, now for the candidates for my maximum. So I've got 1/2e, 1 divided by, and I want to put that 2e in parentheses just so I know that I'm dividing by both the 2 and the e. Okay, 0.1839, all right. And now 1/16 times the natural log of 4, or the natural log of 4 divided by 16. I get a number that's smaller. And so my max is going to be 1 divided by 2e. All right, so this was our process of solving these same problems of absolute maximum and minimum involving situations where we have e's and natural logs.